Okay, so this is Lab 3 for ENEL351 on February 12th, 2022. So for this lab, we had to generate a voltage from our ENEL351LAB3DEMO. Microcontroller measures that and outputs the result to this rudimentary display here according to this table here of voltages and ADC values. So in my code here, there are a couple new functions that I added to the util.c here. So first we have this analog enable, and this just turns on the corresponding ADC. So in this case, our microcontroller has a couple of them. So it just takes the ADC num that you give it and turns it on the appropriate one. Then we've got your analog read here. So it tells it which ADC you want to use and which pin that ADC will read from, or channel here. And so then it just does, so in this case, ADC number, so number 1, and then it sets the SQR3 register of ADC1 accordingly. And then of course, here you enable the conversion. Then in this little while loop, you just wait for the conversion to be done. And then of course, I go and reset the SQR3 register here for later when we want to come back to this again. And then we just return the result from the ADC1 data register. It's nothing too fancy. And then of course, you have the same thing going on for if the ADC is if you're doing ADC2 here. Nothing fancy. So then main.c here. So we'll go up to the top. So of course you got the usual clock init function here. Then we got our analog in pin here, which is pin 2, according to my table. So this is actually PA4 of the microcontroller, and that's of course set up in pin mode here. So first we do this analog enable, and so that turns on our ADC1. Then we do pin mode, so pin 2, which is PA4, and then of course we set it for in analog, which of course we defined in analog here to be 4. So set it up to be input analog. Then of course we got our LEDs here from pins 5 through 8, which corresponds to PA 7 through 10. Then we do our pin mode for our LEDs to set them all as output push-pull 50 megahertz. And then we define this analog value variable here. Then we go into our main program loop. So we do our analog read on ADC1 and our PA4 there. And then we just light up the value accordingly, or light up the LED accordingly. So nothing too crazy going on here. Now for a demo. So we've got our Scopy software up here for the ADLM. And as we see, on the positive output voltage supply, we have 0 volts. And so that corresponds now to LED 0. So now, what happens if we put a 1 volt on there? Well, 1 volt falls between 0.825 and 1.65 volts. So that means LED 1 will turn on here. And go. And you see LED 1 comes on. Let's just turn that around there. So now you see LED 1. And of course, if we do 2 volts, well, 2 volts falls between 1.65 here, or greater than 1.65 to 2.475. So get our 2 volts. We get that LED 2 on. And then we will go up to 3 volts, which will make the last LED go on. And there you go. All the LEDs turn on. That is my demonstration.